In this video, we look at the behavior of the binomial probabilities. Let's let x be a binomial random variable with parameters n and p. Remember, n means the number of trials, p is the probability of success. Now, as k goes from 0 to n, the probability that x is k first increases monotonically and then decreases monotonically, reaching its largest value when k is the floor of the value n plus 1 times p. Now let me explain what is the meaning of floor of n plus 1 times p. The floor of n plus 1 times p is the largest integer smaller than n plus 1p. So let me explain it here. So let's say if you want to find the floor of 5.89. What's the floor of 5.89? Well, the floor of 5.89, let's say 5.89 on the number line is right here, and here is 5, is 5. This is the greatest integer smaller than 5.89, right? The 5 is the greatest integer smaller than 5.89. So that's the floor function. All right, so let me erase that. Alright, so how do we prove something like this? Well, what we're going to do is we're going to look at the probability that x is k divided by the probability that x is k minus 1. Now this is going to be equal to, well, we have the PMF for x, so from the PMF we know that this is n choose k, p to the k, 1 minus p to the n minus k, and we know this is n choose k minus 1, p to the k times 1 minus p to the n minus k. Now this is equal to, this is p to the k minus 1, and this would be n minus k minus 1, like that. So this would be equal to n choose k divided by n choose k minus 1. You get a p's cancel out, so you get a p. The p to the k and p to the k minus 1 reduces to just a p in the numerator. 1 minus p to the n minus k, 1 minus p to the n minus k minus 1, that's going to reduce to 1 minus p in the denominator. Okay, so this will be equal to, I'm going to write the binomial coefficients in terms of factorial, so I'm going to get n factorial over k factorial n minus k factorial times p divided by n factorial over k minus 1 factorial times n minus k plus 1 factorial times 1 minus p. And we have to do some algebra here, so this would be n factorial over k factorial n minus k factorial times p times what we're going to have here is n factorial times 1 minus p k minus 1 factorial n minus k plus 1 factorial and then you can do some cancellations here. So this will be equal to n factorials cancel out, okay, and k minus 1 factorial, and we'll okay, maybe I should write one more line, sorry. Let's write one more line. N factorial times p, k times k minus 1 factorial for k factorial. This will be n minus k factorial. Here I get k minus 1 factorial. This will be n minus k plus 1 times n minus k factorial over n factorial 1 minus p. Now finally let's cancel out what we can, and so finally what I'm getting is n minus k plus 1 times p over k times 1 minus p. Alright, I need some room here, so let's make some room. Alright, so finally what I'm getting here is that the probability that x is k divided by the probability that x is k minus 1 is equal to n minus k plus 1 times p over k times 1 minus p. Now notice that this is greater than, this ratio will be greater than or equal to 1, okay, greater than or equal to 1 if and only if, okay. So basically what I'm doing is that I'm solving this inequality for k, and if I do that, what I'm gonna get is k would be less than or equal to n plus 1 times p. So go ahead and solve that inequality for k, and what you're gonna find is that k is less than or equal to n plus 1 times p. Okay, so basically then what we are saying is that what we are saying is that the probability that x is k divided by the probability that x is k minus 1 is greater than or equal to 1 if and only if k is less than or equal to n plus 1 times p. Okay. Alright, so that means that the p of x equals to k is greater than or equal to p of x equals to k minus 1 if and only if k is less than or equal to n plus 1 times p. So what it means is that as long as k is less than n plus 1 times p, p of k is going to be greater than the previous p of k minus 1. But if k is greater than n plus 1 times p, then p of x equals to k would be less than, okay, p of so let me write that down. So what this implies is that if k is less than or equal to n plus 1 times p, then p of k is greater than p of k minus 1, and if k is greater than n plus 1 times p, then p of k is smaller than p of k minus 1, which implies that the conclusion of the proposition that the maximum binomial probability occurs when k is the floor of n plus 1 times p. Alright, you don't have to worry about knowing the proof for any exams or quizzes, but those of you who are interested, you can look at the proof and see if you can understand the proof. Alright, so I'll see you in the next video where we will look at the mean and variance of the binomial random variable.